Hey everybody, Joe Baker here with the Edit Bay. In my last tutorial, I touched on some software tweaks you could employ to reduce freezes and crashes while using your post-production software. Tonight, we're going to take a look at hardware upgrades that can improve your post-production experience. Before we dive into this, let's clarify just a couple of things. First, I'm going to be using my own workstation as an example here, and my workstation is a PC. So although some of these same concepts do translate to Mac users, I'm going to be using PC terminology. Also, I'm going to be making suggestions with the assumption that you're interested in possibly upgrading certain components on your machine, as opposed to building a custom editing workstation from scratch. Building your own workstation is the best way to get a big, badass machine optimized for video editing while giving you a ton of bang for your buck. But if you're tech savvy enough to build your own machine, you're probably already aware of the concepts I'm going to be covering here. So my machine is an Alienware Aurora R4, which is a gaming PC. While I'm not a gamer, some of the hardware in the machine did work well for video editing, and some didn't. I've upgraded several components over the years. While we're looking at this, you can use my machine as a point of reference. It barely meets the minimum requirements for online 4K editing. There's room for improvement. But if you're currently experiencing laggy playback, slow rendering, freezes, crashes, consider what's currently in your case and where your money might be best spent on upgrades. First, we're going to take a look at your boot drive or your C drive. Ideally, you want only your OS and your applications on this drive, and you want that drive to be as fast as possible. These days, that means SSD or solid state drive. If you're currently running a standard HDD, you could see very noticeable speed improvements by just picking up an SSD. Your computer will boot up in about a third of the time, and apps will launch in nearly half the time. They're a little pricey. You're probably looking at about $300 or so for a 480 gig SSD. That's what I've got here, and I got it on sale for about $2.50 during the Christmas season at Best Buy. Next, you've probably heard a lot of people talk about the importance of a fast GPU for video editing, and we'll get to that. But the truth is, when it comes to video editing, your CPU is doing most of the work. So you've basically got two options for CPUs, AMD and Intel. Go with Intel. Intel is almost always a step or two ahead of AMD. And if you're curious about upgrading a CPU, yes, it is possible. It's pretty straightforward. Getting to your CPU is more often more difficult than actually replacing it, meaning you'll have to move a lot of other components out of the way in order to get to your CPU. And you're going to have to make sure that whatever CPU you'd like to add to your system is compatible with your motherboard and won't create any kind of bottleneck. You want a CPU with multiple cores, and if it can be overclocked, even better, assuming you have a solid cooling system and adequate ventilation to handle the additional heat. I'm going to delay talking about GPUs yet again, because there's another component that's even more important. As you probably already know, video editing apps don't actually edit your video. What they do is they create a set of instructions for creating a completely new video file. And to do this, they reference other video files as well as other assets. So since your NLE is constantly looking at your source media, you need that media to be on drives that can transfer that information as quickly as possible. So here you have several options. I'll go ahead and pull up my drives right here. I have two 3 terabyte HDDs configured in RAID 0 that I use for my project files, my source media, and my assets. So you can see I've just named this drive RAID. A RAID, by the way, stands for a redundant array of independent or inexpensive disks. They can be configured in many ways, but the way that makes most sense for us, for video editors, is RAID 0. In RAID 0, 2 or more drives work in tandem, striping or spreading various bits of data across the array, effectively increasing bandwidth. And of course, since SSDs are even faster, you could configure 2 SSDs in RAID 0 for even more speed. But a word of caution with RAID. RAID 0 is ideal for fast data transfers, not long-term data storage. In RAID 0, all of the drives in the array behave as one, and no single drive in the array contains every bit of information necessary to build a particular file. So if one of the drives in the array fails, you lose everything. You can cover your bases by backing up all of your media assets and source footage to another drive. I keep a copy of everything on a portable hard drive just in case. Now, this is a RAID I have set up internally with standard HDDs. You can also get external RAIDs that you can connect via Thunderbolt, SATA, or even USB 3. Keep in mind that the speed of the drives will be limited by your connection. So a RAID connected via Thunderbolt is going to be faster than one connected via USB 3. Alright, disk cache. As mentioned in my previous tutorial, Adobe recommends having a dedicated drive for your media cache. An SSD is ideal, but you can get away with a 7200 RPM HDD. I have an HDD left over from my previous build that I'm using. In fact, in my next upgrade, I'm probably going to replace that with an SSD. But here's what I've got. I have a folder for every app that uses Adobe's Mercury playback engine. All right, the GPU. The important thing to understand about GPUs is that with video editing, they're not working all the time, the way they are in gaming anyway. Your GPU will speed things up when you're using GPU accelerated effects and when you're using an app that can use your GPU for rendering, such as Adobe Media Encoder. But when it comes to your basic trims, cuts, gain adjustments, and so on, your CPU is doing all the work. And just on a side note, at the time of this recording, your GPU does almost nothing in Photoshop. But for video, part of the draw of third-party plugins such as those from Red Giant is that they are GPU accelerated. So Universe, for example, has many effects that you'll also find in Premiere, but the one in Premiere are running off of your CPU. When it comes time to upgrade your GPU, you've got two choices, AMD or NVIDIA. Go with NVIDIA, especially if you're an Adobe user. Adobe's apps work much better with CUDA than they do with OpenCL. Okay, so to recap, you want your OS and your applications on an SSD, or your boot drive. Ideally, you want your project file, your media, and other assets on the fastest drive or drive configuration you can get your hands on. And you're going to want a dedicated drive for your media cache, and you're going to want a dedicated drive for your output renders as well. Now, I've got this drive doing both, but again, a more ideal setup would be to have an additional drive simply for output renders. So if your editing sessions are a bit sluggish, take a look at your hardware. Is there a component that could be easily upgraded? If you've been editing your footage off of a portable hard drive, do you have enough slots in your case for a couple of HDDs you could configure in RAID? Is your OS on an HDD? Can you spring for an SSD? Does your machine have a Thunderbolt port on it? Have you considered looking into an external RAID? If you're an Adobe user, to what drive is your media cache being written? These are all things that we should be asking ourselves if we run into these issues with sluggish playback, your computer choking on high-res footage, crashes, these types of things. All right, that about wraps it up, everybody. I really hope you found this tutorial helpful. If you did, please feel free to hit the subscribe button. If you have any questions or comments, please post them in the box below. I'll see you next time.